Ramos and I'm a 4th-year student of Sagay National High School Special Science class. And this is my video presentation. In this video, I will be discussing about one of my favorite topics in physics, Isaac Newton's laws of motion, the law of inertia, and law of acceleration. We'll first talk about the first law of motion, the law of inertia. When you hear the word inertia, what comes into your mind? Science speaks. Inertia is the tendency of a physical object to remain still. That is how Isaac Newton got his first law. This law states that an object at rest will remain at rest, and an object in motion will continually move in a straight path unless acted upon by an outside force. To further explain the law of inertia, I will show to you an activity that people of all ages could perform in their own homes. In this activity, we will be needing only two materials, one hard-boiled egg and one raw egg. Now what to do with these two eggs? First, let us spin the hard-boiled egg. When it starts to spin fast, slowly put your fingers down to put a stop into it. When it starts to stop, remove your fingers quickly. Observe what happens. Now, let us spin the raw egg. Do the same procedures as you did with the hard-boiled egg. Observe what happens. In our activity, we have observed that when we tried to stop the hard-boiled egg, it did completely stop. But unfortunately, in the case of the raw egg, it didn't stop, but instead, it started to turn again. This is because the motion of the liquid inside the egg is still ongoing. The force that we have applied to stop the egg wasn't enough to stop both the inertia of the outer shell and the liquid inside of it. But if we held the egg longer enough force must have been applied to stop the egg completely. The results of the experiment fit in with the law of inertia. An object will continue to remain in one state until sufficient outside force acts into it, either to bring it into motion or to put it to rest. Now we will be talking about the second law of motion, the law of acceleration. According to this law, the acceleration of an object is dependent upon two variables, the net force acting on the object and the mass of the object. According to Newton, the acceleration of an object produced by a net force is directly proportional to the magnitude of the net force, and the same direction as of the net force, but inversely proportional to its mass. This verbal statement can be expressed in an equation as To understand more about the law of acceleration, I will show to you an activity using a crumpled paper and a rock. Now what to do with these two things and how can these two show the principle behind the law of acceleration? Simple, just drop these two at the same time. Observe what happens. Based on our activity, they both fell at an equal rate. Their acceleration was constant due to the force of gravity acting on them. But then, the rock made a greater force of impact compared to that of the paper. This is where the law of acceleration comes in. Since according to this law, acceleration is equal to force all over mass, if we transpose mass to the other side of the equation, we would have force is equal to mass times acceleration. But since acceleration is constant, we could cancel this, thus resulting to force is equal to mass. Therefore, a greater mass needs a greater force. That explains why this rock made a greater force of impact compared to the paper. first two laws of motion, the law of inertia and law of acceleration. Hope you fully understood those two based on the activities that you have done. See you again next time!